All right, so welcome to the video on dividing rational expressions. Um, so when you're dividing rational expressions, it actually works a lot like multiplying rational expressions. You just have one extra step in the front. So just to start off, to kind of see what one of these things look like, it's basically when you have one rational expression, which is a polynomial over another polynomial, and then you're dividing it by another rational expression. Now this looked, like I said, a lot like multiplying. The only difference is now we have a division sign in between. But that is easily remedied. If we kind of think back to when we were dividing fractions in the past, I think you learned this like in elementary school up through middle school and beyond. But basically, when you're dividing a fraction, it's very similar, not similar, it is the same thing as taking the first fraction and instead of dividing, turn it into multiplication by the reciprocal. Okay? So if you think about kind of a different example, if you have 10 over 9 divided by 2, that's the same thing as 10 over 9 times 1 over 2 because the 2 got flipped over. So main point is just flip the second fraction over and turn it into multiplication. Now, instead of multiplying 10 times 35 and getting 350, and just multiplying out and getting larger numbers and simplifying later on, it actually works out better if you go ahead and turn these into whatever their factors are. So 10 is a 5 times a 2, 35 is 7 times 35, 9 is 3 times 3, and 6 is a 3 times 2. Then actually multiplying it that way. Now you get larger numbers on top, or not larger, but more numbers on top and bottom than if you're just going to multiply this. But the nice thing is that you can simplify along the way. So now I can just take off the 2's, and that's it. Now, if you watch the multiplication video, we basically started on this step right here. So the only new step is when you see division, turn it into multiplication and then work it out like we did with multiplying. Right? So the key to this basically is figuring out the multiplication part. All right, and so basic steps to dividing fractions. That should be not fractions, but dividing rational expressions. So yeah, is rewrite as a multiplication problem. Then you're going to factor all of your numerators and denominators. Write as a single rational expression. And then cancel factors that match. That's a simplifying step. And then we still need to identify any restrictions on the domain. And if you remember, that's whatever makes the denominators 0. Okay? So let's see this in action. So first example, we got a rational expression divided by another rational expression. So first step, we're going to rewrite as a multiplication problem. Okay? So instead of this division, we're going to take this first fraction or rational expression and write it the exact same way. The first rational expression does not change. Your division turns to multiplication, and then you're just going to flip this other one over. So the denominator becomes the numerator, and the numerator becomes the new denominator. Okay, so you just flipped it over. All right. So, and there you go. So the first step, pretty easy. Just flip the second one, turn it multiplication. Second step, actually from here on in, it's basically the same steps that we used for multiplying rational expressions. So, because at this point, it's a multiplication problem. So again, if you watch the multiplication video, it's just a matter of factoring basically all four parts. So I'm going to do a little bit of side work here. So x to the fourth minus 9x squared. So if we go ahead and factor that out, check for GCF. GCF is an x squared that can come off of both of those. So I'm going to go ahead and pull those off. And then I got an x squared minus 9 left over. Okay. Now, it turns out x squared minus 9, I can keep going with this. You got to keep factoring until basically you can't factor anymore. So x squared minus 9, that's a difference of squares. If you remember your patterns, I got a perfect square minus another perfect square. So that just factors into x plus 3 and x minus 3. So that first part just factors into that. Okay. Second part, x squared minus 16. That is another difference of squares. So you have a perfect square in front and a perfect square in back. And they're being subtracted. You have to make sure they're being subtracted. So that's just an x plus 4 and an x minus 4. So this is where the patterns come into play. So if you recognize these patterns, use them because it makes it really fast. So I got my first numerator, my other numerator. Let's start with the next denominator. Okay, this is a trinomial. first thing I check for is a GCF. No GCF, so go ahead and try out the splitting the middle term and then do factor by grouping. We use this X thing if you remember. So front times back, there's a 1 here. 1 times 3 is 3. Middle term's a -4. So that must be a -1 and a -3. -1 times -3 is 3. -1 times -3, sorry, plus -3 is -4. I think I said -3, it's a positive. All right, so -4x turns into minus -x and a -3x. Now we're just going to do factor by grouping. So you take out an x from this first part. So x comes out, x minus 1. You have an x minus 1 over here. So you need to ask yourselves what would be outside to make this work. It must be a -3. Okay, take those out. And you got an x minus 3 that goes in. Now keep in mind, whenever you have an a value of a 1 here, you don't actually have to do this grouping part. Your answers are right here, the -1 and -3, -1, -3. You can pull it right from there. But remember, that only works when there's a value of 1 here. All right, so that's your bottom part. Next part, another trinomial. Don't go right into the x part, because looking at this, I do notice that there is a GCF that can be pulled out. Okay, x to the 4th, x cubed has an x squared, and -8x squared also has an x squared. So all 3 of these terms have x squareds. All right, so you can pull that off of all 3. Leftovers go inside of parentheses. And keep checking. This is a trinomial that can be factored using the x to split the middle term. Again, your a value is a 1, so after you do this part, you actually are done. It's x plus 4 and x minus 2. Just bring down your x squared. That way you have your entire expression right there. So that goes on the bottom. All right, so next step, write as a single rational expression. This is another easy step. Again, the longest step is this step 2, the factoring piece. So step 3, you're going to write it as a single expression. It's an easy step, but it's necessary in that these two are still saying they're going to be multiplied. You haven't multiplied them yet. So to actually show that you multiplied them, it becomes one large single rational expression because it's one division bar. Now, if you notice this x squared, I pulled it out front. Any monomials you should pull out front. That way you can see your groups kind of clearly and your single monomials clearly as well, because that's going to be its own simplification process. All right, so now let's start to quote unquote cancel. They're not really canceling because they're ones there. So first one's x minus 3s. Next ones I'm seeing is x plus 4s. Okay, and then no other groups match up, so look at the monomials. These ones actually match perfectly, so you can take off those ones. And then that's it. Remember, you can't start canceling pieces of groups. It has to be the entire group or nothing. These x squareds were considered their own kind of groups. You didn't need a grouping symbol, though, since it was only a monomial. And that right there is your answer. So this divided by this is this. Now, I think some tests and things like that, you might see these actually multiplied out. So you would do like the box method or distribution to multiply the top and the bottom. I'm okay with you leaving it in factored form, so you don't have to multiply it out after this. So just leave it like this, and you're done with that. Now we do have one last step. That last step is to identify restrictions on the domain. Now, this is a little different than multiplying. We want to figure out what makes the denominator 0. But if you take a look at this, we actually have 3 parts we got to keep an eye on. So the first part is at. I mean, that's obviously a denominator because it's on the bottom of a fraction. This is division, so you're dividing by 0. Another one that's pretty clear is this one because you got a fraction right here. That's dividing by 0. Now, we have an actual third fraction here. We have this division sign. So if you think of this like, I probably should have inserted like a slash or something, but if you think of this as like a division bar, this entire thing is a denominator. So not only can you not have this part be 0, you also can't have this part be 0 as well. Um, Another way you can think about this is after you turn into multiplication, this numerator actually becomes a denominator in this step, so it cannot be 0. So I basically, whenever you're doing division, just make sure that these three parts are not equal to 0. Now the easiest thing to do is look at the factored step. So I already did all the factoring, so I'm going to look at this step right here. So the first set is this, okay? So we got our x squared minus 4x plus 3. That factored into x minus 1 and an x minus 3. So now we got to ask ourselves, what turns this into 0? So first off, if I have a 1, 1 minus 1 is a 0, so 1. What would make this part 0? Probably a 3, so 3. Okay, and that's it. So those are my restrictions so far. So if I plugged a 1 or a 3 into this beginning one, it would turn this into an undefined expression. So yeah, that's not allowed. Next one is going to be, I think this bottom one, yeah. So, and remember this x squared minus 16 became the numerator, so I'm looking at this top part. You're going to be looking at the top and the bottom anyways, since it's top and bottom, no matter if you flipped it over or not. So basically just all this can't be a 0. So plus 4 can't be a negative 4, minus 4, so can't be a positive 4. All right, and then the last part, it becomes this denominator. Okay, so now we got three parts here. We got our x squared. What would make x squared 0? Only 0. 0 squared is 0, so I can't have a 0 there. It's multiplied by this x plus 4. Keep in mind, we already have negative 4 on our list, so it doesn't make sense to say, hey, don't plug in a negative 4. Hey, don't plug in a negative 4. It's just one time you should say that. So x plus 4 can't have a negative 4. It's already there, so I don't have to add anything. So moving on to this, x minus 2 must be a 2. That will not work. So that's it. So domain restrictions are these. Normally we write domains, restrictions, most things we like putting in order. So from smallest to biggest. So, and that is it for that. Okay. All right, so that was the first example on the PowerPoint. I'm going to do the rest of the examples on, what's it called? My dot cam, my handy dandy dot cam. All right, so with the dot cam setup, we're going to do about 3 more examples. I'm planning on uploading this to YouTube, so you can always kind of go through the video just to see the different examples as you need them. And I don't seem to, okay, got my 4 markers, and let's take a look at this. So if you want to, as far as showing work goes, I am okay with, so the first step is rewrite as a multiplication problem. So the first step, I'm going to put equals our 3x squared minus x over 5x squared minus 5x minus 10 times, and then I'm just going to flip this guy over. So 5x minus 10 and an x. All right. Now we're going to go on to step 2, factor all the numerators and denominators. So I'm going to go ahead and start with the easiest ones that are kind of clear. So like this one, this x, that one's done. There's nothing we can really do to factor that. Looking at this numerator, this one looks like I can pull a GCF. Now I'm just going to factor right on top just so I can kind of see it. Or actually, no, we don't got to factor on top. Oh, yeah, we do. So 5x minus 2. So 5x minus 10. Okay. And then let's do this one in another color. So we got 3x squared minus x. So it looks like I can pull a x out of both of those. I get a 3x minus 1. That's a 3x squared. X times negative 1 is a negative x. Okay. Next one is this bottom one. So this bottom one looks like it has a little bit of work involved. So I can either write it off to the side, but it's in a nice spot right here. So I can just show my work right below it. So I can pull off a GCF first. So 5. I got an x squared minus x minus 2. Okay. So if I do my x method, so it should be a negative 2 minus 1. What times what is a negative 2 adds to be a 1. 2 is only going to be a 2 and a 1. I got to make this multiply to be a negative, so one of them has to be a negative. Must be the negative 2 because they should add to be a negative 1. So this becomes 5x minus 2, x plus 1. I was able to use a shortcut because the a value, this 5 is not the a value. The a value is in front of the x squared, is a 1. So I can just kind of skip right to that. All right, so let me make this next part in green. All right, so I'm on the third step. We're going to rewrite this as a single rational expression. All right, I'm going to pull all of my, so on the top, I'm going to pull both of my monomials, the 5 and the x, out front. So 5 times x times 3x minus 1 times an x minus 2. Okay. Over, now on the bottom, I had this x and this 5, so I have another 5 times an x times x minus 2 and an x plus 1. All right. And keep in mind, we're going to be looking at, we're going to be looking at this step over here to find our restrictions once we start looking. All right, so let's start canceling, quote unquote, canceling. X minus 2's, 5's are gone, x's are gone. I'm left with a 3x minus 1 and an x plus 1. Okay, and just as a heads up, if you have just one binomial over another binomial, nothing else cancels, you can go ahead and take these parentheses off since nothing is on the outside to distribute in. So 3x minus 1, x plus 1. This is the answer. I would be okay if you left the parentheses on though. Okay. Now we need domain restrictions. So domain restrictions are, if you remember, we're not supposed to have this thing cannot be a 0, this can't be a 0, and this can't be a 0. So what we're going to do is we're going to look at our factored steps here. So first off, this first fraction stayed the same, so I just need to make sure this bottom part, which was this, is not a 0. So that's just a 5. 5 is fine. And then going across, we have an x. So x cannot be 0. Okay. What else is in denominators? We have this one in a denominator. So we got x minus 2, so that should be a positive 2. X plus 1, so it can't have a negative 1. Or actually, I kind of did this one early. So we can't have this be a 0 or this part be a 0. These are the fractored parts. So x, we already said x right here. The x's can't be 0. And then if we look at this top part up here, 5x minus 2, so it cannot be a 2. But we already got that. So that's it. Okay. And so I don't need that part. That's our domain restrictions. So that is your answer for that one. Okay, so that's example number 2. We're going to go to do another one. Okay. Example 3. So a little bit more factoring. Now, the examples from here on in, were basically the only things that are going to change is really just going to be the factoring steps. So you might see some trinomials happening more often. You might see the difference of squares. The basic steps are the same though. You're going to rewrite, or up there. See? Up there. So let's go ahead and do this. All right, first step, just rewrite it as a multiplication problem. X squared plus 4x plus 3 over x squared minus 4 times x squared minus 6x plus 8 over x squared plus 2x minus 3. Okay. I'm going to do the factoring a little bit faster on these ones. I can see that all 3 of these things have a values of 1, and this is a difference of squares. So kind of plan it out as you're working through. What this means when we have all of our a values are equal to 1, I just have to do the x part to figure these things out. So I'm going to do that with all these. So if I figure out two numbers that multiply be a 3, add up to be a 4, that's a 1 and a 4, 3, 1 and a 3. So this turns into x plus 1 and x plus 3. All right, next one. If I take a look at this one, two numbers that multiply be an 8, add up to be a negative 6, multiplies be a positive, but it should be a negative, so they're both going to be negative. 4 and 2, negative 4, negative 2. So this is going to turn into x minus 4 and an x minus 2. All right, next one, difference of squares. So I'm going to end up, this is just going to be x and a 2, so x plus 2, x minus 2. Keep in mind, if I'm going kind of fast, feel free to rewind, pause, stop, whatever you need to do, replay it, or ask me questions. You can always do that during my office hours. And this last one's another trinomial, so I have a negative 3 and a 2. Yeah, so 3 and 1, and should be a positive 2, so the 1 is on the negative. The 1 is negative. That'd be a negative 3, positive 2. So I get x plus 3 and an x minus 1. And again, we can only use this kind of shortcut because the a values are 1s. If this was anything else, you would have to do the factor by grouping, like splitting the middle term and then doing all that other good stuff. All right, so we are on step 3. We're going to take all of these factored forms and rewrite it as a single rational expression. Keep a lookout for any monomials that got pulled out of any of these factored parts. Looks like no. So we can just write it as is. Everything on top stays on top. So we got our green part, the x plus 1. We got our x plus 3. We got our x minus 4. And we have our x minus 2. Okay. The denominator is an x plus 2, an x minus 2, an x plus 3, and an x minus 1. So I just rewrote this whole denominator, factored parts on the bottom, numerator parts, the green one and the red one went up top. And let's start canceling off. So we got, cancel these a different color. X minus 2's. We got our x plus 3's. And that's it. All right. So final one is x plus 1, x minus 4, x plus 2, and an x minus 1. Whoops. Okay. Yep, there you go. All right, so that is our simplified form of that. Now I can't take the parentheses off because I'd have to multiply them out. So go ahead and leave it in factored form. Domain restrictions. X cannot be what? So if I take a look back at this step up here where everything was factored out. So first look at your first fraction. You got a denominator. So x plus 2 and minus 2, I can't have a negative 2 here. I can't have a positive 2 here. So x cannot be negative 2, x cannot be positive 2. Okay. On this next part, so remember this part, originally you have one part as a denominator, but then you flipped it over and then the top became the denominator. So basically I don't want either one of these pieces to be 0. So we're going to take a look at this whole thing. So from this top part, we're going to have, it can't be a 4 or a positive 2, positive 4, positive 2. We already have a positive 2, so just positive 4. Okay, from this bottom part, we have a negative 3 will mess this part up, a positive 1. So negative 3, positive 1. Okay, and just for good measure, let's go ahead and put these in order. So you got negative 3, negative 2, 1, 2, and 4. Okay, so if you're already getting the hang of this, feel free to stop I'm going to give one more example though, because like I said, this all kind of depends on your factoring skills. Other than that, because it's this part that has the most work. So other than that, it's the same steps, just with different factoring types. Okay. So third example, and here we go. So first step again, rewrite it as a multiplication problem. And if you want, feel free to pause this video and try this on your own and then follow along afterwards. That is one strategy you could use if you wanted to. Now, just taking a look at this right away, this is an easy one. Not a lot of factoring going on or anything like that. So I'm just going to write this right off to the side. So x squared minus 9, x plus 2 is the same thing as multiplying by the reciprocal. Okay, so that's the same problem. So taking a look at these things, the only thing that really needs to be factored is this top left, the x squared minus 9. That is a difference of squares. But other than that, nothing really else. So this x doesn't factor. Now, if you have a binomial that doesn't factor, it does help to put it in parentheses because you want to consider it a group. Again, you don't need to group this one because it's a monomial. There's not a binomial, so you don't really need a group. Okay, so x squared minus 9, that will be x plus 3. Oh, make my parentheses bigger. X minus 3. Okay, so top part, x plus 3. Oh, I forgot that. Bring this monomial out front, and then go ahead and write these two groups, x plus 3 and x minus 3. We like our monomials out front. There's no monomials on the bottom, so just write these two, x plus 2 and an x plus 3. All right, so let's start canceling off. So we got our x plus 3's go away. And that is it. I can't take this x and cancel it with this one because this is part of a group. Remember, you're not supposed to take off pieces of groups. Okie dokie. So we got x minus 3, and we have an x plus 2 on the bottom. All right. And again, these parentheses are optional on the bottom. On the top, you need it because this x, you have a number outside, or you have something outside the parentheses other than a 1. So x minus 3 over x plus 2. All right. And again, I would accept this one too. Just know that these are the same thing. More than likely, if you had a multiple choice test, it would be written in this form right here. Okay. Domain restrictions is our last part. So going back up to right here. So let's take a look at this first fraction first. Remember, this is a numerator and it stays a numerator the whole time, so I don't really care about that part. I care about the bottom part right here. What would make this denominator 0? It would be a negative 2. So x cannot be a negative 2. Okay, so negative 2 would mess up this denominator. Remember, this top part becomes a denominator, or I'm sorry, over here. It was a denominator, and it's now a numerator, but because at one point it was a denominator, we do not want it to be a 0. So basically, always the second fraction, make sure the top and the bottom are not equal to 0. So this x, what would make this x0 a 0? And what would make x plus 3 a 0? A negative 3. And just for good measure, let's go ahead and put them in order. X cannot be negative 3, negative 2, or 0. Okay, and that's it. So go ahead and try out the homework assignment. If you have any questions, feel free to stop by during my office hours. I hope everybody's doing well, and take care. Bye-bye.